Hi, my name is Nduvo. Please assist me with this question.
Alrighty guys, so this is actually a really great question because there are so many different sets of parallel lines which can make your similarity and proportion a little bit confusing. So let's take a look at this question and try and make sense of it. It says ABCD is a parallelogram. Okay, so it hasn't been shown on the diagram, so let's fill in the information as we go. ABCD is a parallelogram, which means we know that CD is parallel to AB because the opposite sides are parallel, and AD is parallel to BC. Okay, parallelogram. With its diagonals intersecting at O. Okay, so that's where its diagonals DB and AC intersect with each other. It also says that ADE, AC and F is at the bottom here, and ABG are straight lines. Okay, that's very important just so that you know that these form complete straight lines. They're not like weird disjointed lines that could do that, which make your angles go all pear-shaped. Okay. It says that they are straight lines such that DC is parallel to EF. Okay, so if we look at our diagram, DC is parallel to EF. Okay, that helps, because now we know that all three of these lines here are parallel to each other, if necessary. Also says that DB is parallel to FG. DB runs along here, and FG runs along here. So we know that we have a third set of parallel lines, okay? So don't get confused. We have these three lines here that are parallel to each other. We have these two lines here that are parallel to each other, and then lastly these two lines parallel here. Okay. Lastly, our little love letter says if AD is equal to 12 units. Okay, so up here AD is 12 units, DE is 3 units, CF is 5 units. Okay, so CF is down here, 5 units. And lastly, DC is 14 units. Okay, so this may look a bit strange, having this long edge 12 units and this short edge 14 units. But we may just be looking at this triangle. You know, if you have a triangle and it's sitting like this, but if you look at it from a distance and it goes and it changes orientation, some long sides can look shorter. So even if this doesn't look like it's a long side, we might just have the wrong orientation. Okay, so bear that in mind. Okay, so it says, if we have all this information in front of us, firstly, calculate the length of side AC. Okay, so AC is this side over here. Now, obviously, we've been given a whole bunch of parallel lines and a whole bunch of measurements. So we need to try and use sides in proportion to figure this out. So if I look here, AC forms part of the triangle. We've got A at the top, E at the bottom, F at the other bottom. So we've got this big triangle here. And then we've got DC parallel to the base. So we've got DC there, and we know that these lines are parallel. We're trying to find AC here. We've been given that AD is 12, DE is 3, and DC is 14. Okay, so because these two lines are parallel to each other, remember, a line drawn parallel to another side of the triangle divides the other two sides in proportion. So we know that if we're trying to find AC, okay, oh, we also have 5 over here. CF is 5, okay. So if we're trying to find AC, it makes sense to go with AD over DE, AD over DE, is equal to AC over CF. Don't forget to give a reason. Line drawn parallel to one side of the triangle. Okay, so AD is 12, DE is 3, so we get 12 over 3 is equal to AC that we're trying to find, and CF was given to us as 5, which means that AC is equal to, cross multiply, we get 5 multiplied by 12 all over 3, which gives us 60 over 3, which gives us 20. Okay, so that means that this side here, AC, this long side, is 20 units. Okay, when in doubt, just write units. You may lose a mark. Okay, next it says, calculate the length of EF. So we know that this here is 12, this is 3, 14, 5, and we know that we've just found this long length of AC to be 20 units. So now it's saying, find the length EF. Okay, so EF is at the bottom here. So again, we're working in this triangle, AEF, with CD parallel to EF. We have 12 over here, 13 over here, and 14 over there. Okay, so remember, when you're working with your similarity and proportion, if you want to use a long side over a long side, remember you need to add these two together. So if I look, the ratio that I'm going to use is AE, long side over another long side, EF, which is what we're trying to find, is equal to short side over short side, 12 over 14, which is AC over CD. So we know that EF is what we're trying to find, and AE is equal to this whole side, 12 plus 3, so that's 15. Okay, so now we simply cross multiply. EF is equal to 15 multiplied by 14 divided by 12, because remember, you take multiply by EF, divide by 12, multiply by 14. So now I'm going to get my calculator out. 15 multiplied by 14 divided by 12 equals 17.5. So that means that EF is equal to 17.5 units. Okay. Lastly, it says find the length of BG, which is this side here. So let's fill in our information. 12, 14, 5, 3. This we've just found to be 12.5. And remember, all of our parallel lines. Parallel, parallel, and then these two here are parallel. Okay, so we're trying to find BG. Remember, this whole side AC is 20 units. Okay, so how do we find BG? Firstly, I want to try and find the triangle that is a part of. So the big triangle that involves BG is triangle AGF, and then there's a line drawn parallel to the one side of it, which is this line OB. Okay, and we know that OB is parallel to FG because it was given to us that way. Also, we know that this whole side, okay, we have AC over here. So C sits somewhere here. We know that that's 20 units there, and that's 5 units here. So this whole side here is 25 units. Okay. Also, we know that these are diagonals of this triangle. Okay. So if we can find lengths using the diagonals, we can start putting in our lengths on our triangle here because we're trying to find BG. So how do we find AO? Well, firstly, we know that AO is equal to a half of AC. AO here is equal to a half of this whole diagonal. Why? Because the diagonals of a parallelogram bisect each other of a palm. More than enough information. So we know that AO is equal to 10 units. Okay, so up here is 10 units. Now, to find OF, we know that this whole side here, AF, is 25 units. So OF must be 15. Okay, now how do we find AB? Well, remember, this whole thing here, ABCD, is a parallelogram. And what do we know about parallelograms? Their opposite sides are equal. So AB is equal to DC. AB is equal to DC, opposite sides of a parallelogram. You can say palm, otherwise you can say parallelogram. Okay. So now we know that AB is equal to 14 units. AB is equal to 14 units. Okay, so now up here, we've got 14. So now, easy peasy, we just use our ratios. So AB over BG, AB over BG is equal to AO over OF. Don't forget your reason. Line drawn parallel to one side of the triangle. Okay, so we're trying to find BG. We know that AB or AO and OF are 10 and 15, and AB is 14. So we get 14 over BG is equal to 10 over 15. Okay, so cross multiply to solve for BG. So we multiply by BG, divide by 10, and multiply by 15. Big messy diagram, but okay, so BG is going to equal 14 multiplied by 15 divided by 10. 14 multiplied by 15 divided by 10 is 21 units. Okay, so up here is 21. Okay, so fantastic question, Nduvo. Thank you so much for sending it through to us. When you get a question like this, guys, just establish which lines are parallel to each other and which triangles they form a part of. That will help you so much more in figuring out which ratios you need to use when you're trying to find a side of a triangle.